And so, as I was mentioning a little bit, we're going to start where we left off yesterday, just to make sure we're on top of things with that. Even though we call them reciprocal functions, they are rational functions too, just with a little bit easier of a name. So we won't go through all 4 of these. We'll do a couple, just to make sure we're on the right track. So first things first, let's see. For fun, we'll go to 1 and 4, because they're nice and spread out that way. So before we get into this business, first question. What direction are we shifting 4 and 1? Down 1 and right 4. So again, since we're in notes, this is more of a thought process. Down, up or down is going to have to do with y, right or left is going to have to do with x, because that's the way those axes move. So then I can look and go, oh, so my horizontal asymptote is going to be a y equals, so that's going to have to do with up or down. So my horizontal asymptote is y equals -1. Got to keep the variable in with it. What's that? So which one of these two is that going to be related to? Range. Horizontal asymptote and range. Be all reals not equal to -1. So we're going to have all these connectors. All these things with y go together, and then the same thing's going to happen with x. We want right 4, which would be positive. So we've got that, and vertical asymptote, and domain. All the x's go together. And that basically covered us for the lesson yesterday, except for the actual graphs on things. So take a moment, just to make sure we're on the right track here. Give number 4 a run. I will come back up momentarily with values, just to make sure that we're on the right track here. Oh, that's fun, isn't it? Again, as long as we get our directions right, pay attention that our h value is the opposite of what we would think, we're probably going to be in good shape. So again, simple rational functions are reciprocal functions. That's what it's going to look like. But as we forewarned before we just started this, now, instead of just having a number in the numerator, we can have some other stuff. We can have variables, we can have squares, we can have all sorts of fun stuff. So, you're like, okay, what do we got here? Oh, it's one of the infamous boxes. Okay. X-intercepts are the real zeros of the numerator. Okay? So, for x-intercepts, for your zeros, we're going to set the numerator equal to 0 and solve when we can. Sometimes that can be a little tricky. We might need some calculator help, but that's okay. The vertical asymptotes, you're like, okay, so that's x equals, are the real zeros of only the denominator. Okay, so we're going to set the denominator equal to 0 when we're trying to find our vertical asymptotes, which again are going to be our restrictions. The calculator can help us, but we may not want to go that route every time. This we're going to actually see more of tomorrow, but I'll talk about it for a minute here now. A hole, otherwise known as a point of discontinuity, occurs if P of x and Q of x have the same factor. You're like, okay, what in the heck does that mean? So I'm going to draw a little arrow here because I want to make sure I got room to show you what this looks like. So let's say you get something, and it's in factored form, or you factored it out yourself. And we got x minus 4, x plus 2, x plus 2. Okay? You see the exact same factor in the numerator and the denominator, like we do right here. So if that happens, the value of x there, which I'd have to find it, which is basically just changing the sign. If I were to graph that, so let's say it was making a line. I'll do it on here so people that look at this later could see it too. So let's say we're making this graph. If that stuff would go away, we got x minus 4. You're like, well, that's, that's just, I go here, I go up 1 and over 1, up 1 and over 1, and I'm making this graph, and it goes all the way through. But if there's a hole, when I get to this value where x is negative 2, there's going to be a line going there, but there's going to be this empty spot in there. And why you can't physically see that if you put it on a graphing calculator when we get to it, if you pull up the chart, instead of that number showing up, an error message is going to show up. So we're going to have some multiple ways to see it, but it's kind of weird, but that's the only time it happens. More depth on that tomorrow. Just wanted to give you a little peek at it today and see how that works. And then finally, not if there's not enough already, horizontal asymptotes, y equals, are found by comparing the degree, the largest exponent, of P of x and Q of x, your numerator and denominator. And I'm just going to write C below on there because this will explain that, and we're going to put a couple of examples in here as well. So when you're trying to find the horizontal asymptote, it's not just is there an up or down shift anymore once we get x into play. There's 3 things that can possibly happen, and I'm actually going to start on the bottom and work my way up because equal weight is actually the easiest thing to explain. So let's say you had y equals 4x squared over 3x squared. Let's say that was what we were going to graph. Okay? These are equal weight. They have the same degree, the degree of 2. So what you're going to do in this point for your horizontal asymptote is you're just going to divide the lead coefficients. So your horizontal asymptote would be at 4/3. But that's only if those values are the same for those. Sometimes they won't be. So you may see something and you're working it out. You kind of get it. I should be using f of x. Oh well. So if the degree in the denominator is larger, let's say something like this. My degree in the denominator is 2. My degree in the numerator is 1. Anytime that happens, and it could be 3 and 1, 2 and 0, whatever it is, as long as the 1 in the denominator is larger, your horizontal asymptote will be at 0. We don't care about the coefficients there. We don't care about anything else. Bigger degree down below, horizontal asymptote's going to be 0. And then if that flips, if the degree in the numerator is larger, so like if we had 3x cubed minus 7 over x plus 2, larger degree up top, for our purposes in here, The answer for your horizontal asymptote is going to be none. Now, in reality, there is an asymptote, but it isn't necessarily just horizontal. It's going to be like a slant, which has a whole other thing you have to calculate. We saved that for pre-calc. So for here, we just get to call it none for the time being, which is an option. So what you're going to want to do as we're starting to practice these things and work on them in basics, especially with your horizontal asymptote, is get this stuff down. So it's just like second nature. So when you look at it, you're not necessarily having to go to the calculator and look, even though that's a good backup plan if nothing else is working. So let's actually play with some so we can actually put this to use, and maybe it'll be a little less abstract. So let's see here. All right, I'm going to say this right off the bat. If you have pluses or minuses, put the parentheses on immediately. Do not start canceling stuff. That's not legal. Put you in rational function jail. Okay, so we got to find all this stuff. And so you might have to do a little flipping back and forth here at the start. But okay, let's see what we can remember, what we can work here. X-intercept. You have to set the numerator equal to 0. So we'll show the work here so we can remember where this is coming from. And also help to remind us, an intercept is not an equation. It's a coordinate point. So, okay, the x value is -1. What's the y value of any x-intercept? 0. Got to be a coordinate point. Now, the y-intercept is a little more interesting. We haven't talked about that yet. You're like, well, wait a minute, though. The y-intercept just occurs when x equals 0. So if x equals 0, that means anywhere in this equation where there's an x that's really not there. So you can just take what's left over. 1 over -4, -1/4. But I will tell you, there's another way to get it. See, that's the nice thing. We're going to have all these different ways we can go about doing stuff. I normally like to make the calculator my backup plan instead of my primary plan. But if I go here, if I know the y-intercept's at x equals 0, I'm just going to pull up my chart, go to x equals 0, -0.25, -1/4, they're the same thing. And yes, I will take decimals. So that's an option that you have, is going and jumping in that route if you choose to. Bless you. And so I keep looking at this other stuff. I'm like, all right, vertical asymptote. Denominator equal to 0. This? What I did, because 0.25 and 1/4 is the same thing, all I did was, since x is 0, I said, okay, that's going to wipe those things out in this fraction. If I plug in 0, so what do I have left? 1 over -4. Yeah, just pulled it from there. Denominator equal to 0, so let's see, 2x equals 4. X equals 2. That is an equation because it's an asymptote. Draw that in here. Horizontal asymptote, you've got to look at your degrees. So I've got a degree of 1 up here. That's the largest exponent. I got a degree of 1 down here. They're equal weight. I'm not saying this is gross ew. They're equal weight. And so you just take their lead coefficients and divide them. 1 divided by 2 is 1/2. Ooh, we can get fractional asymptotes now. Yeah. That can get a little uglier, but that's okay. But one thing I can say that we can still make the connection on your vertical asymptote and your domain still have the same relationship. That's your restriction. Your horizontal asymptote and your range still have that relationship. Same restriction. And if you really wanted to get cute and show off, when we talked yesterday about the A value, if it's positive, it's 1 and 3. If it's negative, it's 2 and 4. That's still positive. There's not a negative up here. So if you were just doing quick sketch, you'd be like, whoop, whoop, and be done. But we're not going to go quick sketch because we want to be semi-accurate here. Why did I just erase that? Oh, well. Okay, let's put it back in. Okay, let's take a peeky here. So a couple of things I notice now. I'm like, okay, it shifted to the right. That makes sense. It's hard to see, but this is slightly above, so that 1/2 looks accurate too. So when I go here again, the error message is still my vertical asymptote. So, okay, I did good there. And just like we were doing yesterday, when you go to graph, even if you just take a couple of values on each side to help sketch your branches, that is going to work out just fine. Might not get whole numbers every time, but we're going to be semi-accurate as far as making sure that branch is far away enough from my asymptotes to show what we need. And so, mainly the rest of this, these last two examples that we're going to do, 6 and 7, are just going to be getting used to, okay, what part of my setting equal to 0? What am I comparing again? And kind of seeing what that's going to look like. So, okay, x-intercept. Uh-oh. Numerator equal to 0. New thing to play with. Are things factorable? If they are, that's going to be a good thing to do, at least for finding some of our detail pieces. So let's see here. -3 plus 1. We'd solve for those, which again is going to change the signs on all of them if I set each of those equal to 0. So I'm going to end up with -1. And I'm going to end up with +3. Again, intercepts always coordinate points. The y-intercept. You still got the same choices as before. Me, I'm crazy. I'm like, x is 0, so I just get to wipe out all of that stuff. I'll put my finger over that. -3 divided by -4 is +3/4. Or could I type this into my calculator with the parentheses and get the same thing? I don't know. Let's check. Let's check as we go. You can put it in either way. I like to put it in this way better because I'm not going to need the extra set of parentheses, which I'll show you how that can get a little kooky in the next problem. I don't want tangent. Okay. So I go down to 0, 0.75. 0.75 and 3/4, same thing. Okay. So that can help out some. I also, just as an FYI, -1, 0, and 3, 0. There's my x-intercepts too. Vertical asymptote. Denominator equal to 0. Could you do it algebraically? You could. You could just set that equal to 0. I like factoring better, so that's the route I'm going to go. Difference of squares, +2 and -2. If you did it as an equation, you'd add the 4, you'd take the square root. That would work just as well. You're like, wait, there can be like more than one asymptote? Oh, yeah. X equals 2, x equals -2. That is 100% possible. Some of the things that we are going to see over these next few days are going to get kind of wild at times. Horizontal asymptote. We're equal weight again. They're both squared. They're both quadratic. So I'm going to put my U there. Just dividing the lead coefficient. 1 divided by 1 is 1. We got that in there. And then just to mess with your mind, not really. Domain, again, goes with your vertical asymptote. So those restrictions would be the same. Why I didn't put range, I couldn't even tell you. Now here's a new one. We're like, wait. Before it always used to be, branch, branch, or branch, branch. Now what's this craziness in the middle? So let's take a peek at this. And I just did what I did on the last one again. Why I want to keep typing these in, I don't know. Okay, so let's take a peeky at this. Ooh, that's kind of fun. So, okay. So I notice in looking at this, I'm like, okay, there's a vertical asymptote. There's another one. But now here's the part that's interesting. Like, wait a minute. So you've got this horizontal. That looks like it's going through it. I thought the asymptote was like a do not cross line. It is for your branches. When you get these oddball pieces in the middle, you can get a thing that looks like a parabola or something like this. It doesn't necessarily follow the same rule. So it's possible. It doesn't happen often. But when we're graphing, we're going to kind of play by the same rules we have been. Find that. We're going to go ahead. We're going to take a couple of points here. So there's one of my regular branches. I'm going to jump over here to the other side. We'll get the middle in a second here. So we got 3, 0, and 4. We're getting really close. This one, it is going to be tricky to determine because a lot of times you're not going to get an A value. Like with these, my A value is 1 since I don't have a lead coefficient. If it started to get bigger, like 3x squared or 4, that's when you're going to start to see them pull a little bit more than that. Good question. Well, what do I do in the middle then? So in the middle, I've got these 3 values. So if I was just to plot those 3, just to kind of give me a little bit of an idea here, you're like, all right, this is weird. It's like, okay. Might even have to go back and look at the graph for a second. So the branches are still following the rules of a regular rational function. But again, that piece in the middle may get a little bit like a rebel. It's like, okay, I'm not going to follow your directions. So here's the general rule of thumb. They will always respect the vertical asymptotes, okay? All of your parts will. The horizontal one, it's sort of like the teachers, you can kind of bend that rule a little bit. Let's see how far we can go. That's kind of what's going to be going on with the horizontal asymptote. So that's about as funky as this gets. But, well, until we hit zeros tomorrow. So this last one. There's 2 things that can absolutely get you if you're not careful. So let's do a couple things here. I'm going to put parentheses on that first, because that was the only one that didn't have any. Let's start working through this and see how this goes. So you're like, all right, Hardy, why'd you put domain and range first? I don't know, messing with you again. Let's do the asymptotes first. So vertical asymptote, denominator equal to 0. So I get 1, I get negative 4. So we have 2 again. Horizontal. Now, here's where you got to be careful. Because at first look, you look at that, you're like, well, it's 1 and 1. They're equal weight again. let's take a different look at this one. If I were to multiply this out, now if I look at it, I'm bottom heavy because the larger degree is down here. So when I'm bottom heavy, my horizontal asymptote is going to be at 0. So if they're factored out, you do have to watch a little bit, because that can get a little screwy. But once you survive that portion, again, vertical asymptote is x, so is domain. Knock those out. Horizontal asymptote's y, so is range. Get those knocked out. So then we're like, all right, let's see what else we got here. So zeros, normally that is going to be, ooh, now let me ask something. So what's another name for a 0 again? Look at some of the other ones we've done and see what x-intercept. Oh, so you're even going to change words? Sometimes. And so I look at that and I'm like, all right, so again, numerator equal to 0. So it looks like that's going to be -5. We're going to check these things out. This ought to be interesting, because we're about to find something out, but I'm just going to play along. And then my y-intercept, yes, I can go to the calculator, or I can just cover up all my x's that became zeros and get fractional. Again, you'll see in the calculator in a minute, I can still go that way. So I pull out my calculator, and I'm like, okay, I go to type this in. Here comes the caution. If you're going to leave it this way, and there's multiple sets of parentheses, you have to put another set in when you go to divide. So you're going to have double parentheses at the start and double parentheses at the end. Personally, what I like to do, I like in that situation to multiply it out and just use that when I type it in, because there's less of a likelihood of me forgetting a parenthesis somewhere. They'll both get me to the same spot if I do this right over here. Just saying. So I play the graph game. Ooh. That's kind of funky too. Okay. So let's check some stuff. So, -4 and 1, cool. -5, 0, there's my x-intercept, cool. Okay. And my y-intercept is at 0, 1.25, 5/4, same thing. Great. Okay. So it's like a built-in answer key for me. So the rest of these, let's get these in. -5, 0, you're like, wait a minute. -6, we're just underneath. Like, wait. I thought you said, Hardy, that the branches are going to respect the asymptotes. Vertical, they do every time. Horizontal, they just, sometimes they decide they don't want to for some reason. And it's never a good, some of you are like, it's kind of like what I do with things in here. Sometimes I'm cool with it, and other times I'm like, nah, I ain't doing that stuff. Then you even look again, you're like, wait a minute. I thought the branches were supposed to be opposites. Yeah, these rational functions, once you start getting into squareds and stuff, they get funky. I'm not, oops, wrong button. I'm telling you, they get a mind of their own. This even gets funkier. And I am never going to check, like, to a point exactly what you're doing with your graphs. Like, if some of you would have put something that looks more like a parabola in here, I would understand why. That's what you're used to seeing. That's why use the calculator on those and try to be as accurate as you can. But do stay within your vertical asymptotes. Because that's one thing that's never going to change with these. And I want to make sure that we're on top of that. Your biggest goal when you're practicing on these 5 problems that you're going to get, can you start to get to a point where you're doing this stuff without staring at the calculator for everything? That's going to be what's important, because I might flash an easy 1 or 2 of these on that no-calc quiz next week. Because I want to see, can you recognize your parts and your pieces? Because that's going to make this a lot easier. Okay, that's where we're going to cut off. So you have an option on the assignment today. It's one and the same either way. So as far as the assignment goes, it's just page 3 in the practice. Labeling all the things, you're not having to graph. If you are more interested, you're like, I like playing around and having pictures. Tell me what's going on here as we go. I've got the exact same thing over on Classroom in a digital way. So let me show you something with that quick. In case you want to go that route, that way you're like, I'm just done this way. All right. So here at the top, let me pull this up. You would want, if you were going to do this, to make a copy, because I'd actually like to be able to keep mine. That'd be awesome. And I don't want you turning it in. Your name is not your name. I mean, you can even erase my name. I don't care. And I'm still going to put my own. Make my copy. So if you're going to go this route, because that way you can kind of check answers as you go too. Up here at the top, you're like, Hardy, I thought you said there's only 5 questions. Well, yeah, but there's like 6 pieces. So these are the same ones that are in your guide. And so let's say you're doing it, you're like, okay, so domain. You're like, domain, denominator. It can't be -8. Now, how are you going to type this? And I put this in the stream too, in case you do it. You'd have to literally type in all reals, except, and since it's domain, except x is not -8. If you just type in x not 8, it's going to say it's wrong. Even though it's right, it has to understand what you're saying. Domain and range are the only ones that are tricky for that. Like for the others, vertical asymptote, x equals -8. Watch it make a fool of me. Okay. Horizontal asymptote. You're like, hey, this is even better. This is like yesterday's. At the start they are. Y equals -3. Okay. Intercepts are going to have to be coordinate points. So when you get to those, that's going to get a little more interesting. It's not going to be terrible. But like, let's say, I'll be nice again because I did mine already. Ours are going to be in fractions on this, even though I'm willing to take decimals on the other part, this will not take decimals. I'll warn you in advance. So when you're typing these, this is kind of something that you're going to want to keep an eye on, and why I'm putting it on the video in case you're like, crap, why isn't it taking... That's why. Otherwise, if you're like, nah, Hardy, I'm good, you can do it on here, and then you'll either have to get the answers from my key up front, or you'll have to wait until you come back tomorrow and do it that way, because I do not have them all posted online. The only way to get immediate satisfaction is from